Hey guys, in this video I'm going to be going over the examples in the solving equations part of the Pre-Calc Advanced Summer Packet. We're going to start with example P. Here it says to solve the equation. So you have two options. You could distribute this 6 right here, or you could divide both sides by 6. It really doesn't matter. I have a feeling most people are used to distributing, so let's do that first. If we distribute, you'll get 6x plus 18 equals negative 18. And then your job is just to solve for x. Get the x by itself. So I would first work on getting rid of this 18. You could subtract the 18 to the other side. So they cancel over here. We're left with this 6x equals negative 18, and negative 18 equals negative 36. And then to get the x by itself, all you have to do is divide both sides by 6. And you get x equals negative 6. And of course, if you wanted to check, you could plug that back in and double check that it does equal negative 18. You could probably think about it in your head. Negative 6 plus 3 is a negative 3, and 6 times negative 3 is negative 18. So it works. Example Q. Here it says solve the equation using the least common denominator. All right, so many of you might want to distribute the 1/5 and the 1/3, but you're going to get a bunch of fractions. It's going to be really messy. That's not the easiest way. All right, they say use the least common denominator. So here we have a denominator of 5 and a denominator of 3. To figure out that least common denominator, we could just multiply those denominators together. 5 times 3 is 15. All right, you can choose to multiply both sides by 15. Or you could multiply both sides by 5 times 3. It's the same thing. I usually like to keep it separate and multiply both sides by 5 times 3. Just the way that looks, then I look at it and say, does anything cancel? If you look, you have a 5 on top and a 5 on bottom. Those are going to cancel out. On the right side of the equation, you had a 3 in the denominator. Now you have a 3 in the numerator. You can cross the 3's out. So basically what you're left with is 3 times 1, which is 3, times the quantity x minus 2. Over here, 1 times anything is just itself. We're really just doing 5 times this parenthesis. And I might rewrite the 5 right here and multiply it by that parenthesis. All right, so that step right there, multiplying by that least common denominator, which was 5 times 3, or 15, that just clears those fractions and makes it really nice numbers that should be easy to deal with. So from here on out, I would distribute. We're going to get 3x minus 6. Over here, we're going to get 15x plus 5. And from here, we want to get all the x's on one side of the equation. I might start with this 3x. We could subtract it to the other side. If we do that, we're left with negative 6 equals 12x plus 5. Then I would try to move this 5 to the other side. We can subtract it over. All right, we're going to be left with negative 11 equals 12x. And if we want to solve for x, we just need to divide both sides by 12. And we end up with x equals negative 11 twelfths. All right, moving on. Example R, it says solve the following equation. I think it's kind of hard because this side is a fraction and this one isn't. So usually I try to get rid of the fraction by cross multiplying. Before I do this, I'm going to put both of these in parentheses. They're a quantity. They need to hang together. And I'm also going to put this 3 over 1. You can put any number over 1 and it doesn't change the value. So if we cross multiply, we can cross multiply because there's an equal sign there. We're going to be multiplying 3 times the quantity 3z plus 4. And over here, 1 times anything is really just itself, so we're just going to get that 2z plus 7. And you really don't need the parentheses if there's nothing else next to it. On the left side, I would then distribute. We're going to get 9z plus 3 times 4 is 12. On the right side, that doesn't change. 2z plus 7. Then from here, I would move all the z's to one side of your equation. So we could subtract this 2z to the other side. If we do that, these cancel. 9z minus 2z is 7z. Bring down the plus 12 equals 7. Again, we're trying to get z by itself, so we could subtract this 12 to the other side. Right? If we do that, we're going to get negative 5 equals 7z. And we just need to get z by itself. Divide both sides by 7. Sorry, this is getting a little messy. Our 7's cancel. We get z equals negative 5/7. Moving on to example S. Solve the following equation. This one can be solved by factoring. If you look at this left side, we could factor this into two sets of parentheses. So we could split x squared into x and x. Then we could think about numbers that multiply to 20 but also add to negative 9. I'm thinking 4 and 5. 4 times 5 will get you to 20. If we wanted to add to negative 9, 4 plus 5 is 9. We just need to make both of these negative. And then there's a rule from there. If you're multiplying two quantities together and the answer is 0, it's called the zero product property. You could take each of these parentheses and just set them equal to 0. X minus 4 equals 0 and x minus 5 equals 0. And you could solve for x from there. You could add this 4 to the other side and you get x equals positive 4. Over here we can add 5 to both sides and you end up with x equals 5. Those are our two answers to example S. Last example for solving equations is example T. This one looks similar to the last one, but the last one was nice because it was equal to 0. So when you want to solve an equation like this, I would try to move all the terms to one side of the equation so one side has a 0. So probably the easiest thing to do is to just subtract this 4 to the other side. So we end up with 6x squared minus 5x minus 4 equals 0. All right, now it looks like we have to try to factor this. These numbers, 6, 5, and 4, they don't have anything in common. So I think this is going to be the kind of factoring where we have to just guess and check. All right, and this might be tricky. There's a few ways to split up 6x squared. You know, you could split 6 into 6 and 1. You could do 3 and 2. We just have to take a guess. I'm going to guess 3x and 2x there. 3 times 2 is 6, and x times x is x squared. Then we need to think about numbers that multiply to 4. If you think about numbers that multiply to 4, 1 times 4 and 2 times 2. All right? And I'm just really not sure what to do, so this is a guess and check. This is definitely one you want to have a pencil to do. I would maybe pick 1 and 4. Let's just try it out. I'm going to worry about the signs in a second. But if we put 1 and 4 in there, the outer terms get you 12x and 2x. Is there any way that we can add 12 and 2 or subtract 12 and 2 to get 5? And I don't think that's the case. I don't think it's going to work out. So I might flip them. They might just be in the wrong spots. How about if we put 4 and 1? If now we think about those outer terms, we get 3x and 8x. Is there any way we can add or subtract 8 and 3 to get 5 or negative 5? And I think if we make negative 8x and positive 3x, negative 8 plus 3 is negative 5. So if we put a negative here and a plus here, that should work. If you're not sure at this step, you could FOIL this out and make sure it equals this. All right? Once you are sure, you can use that zero product property and set both of these parentheses equal to 0. 3x minus 4 equals 0, and 2x plus 1 equals 0, and you could solve from there. If you add this 4 to both sides, you end up with 3x equals 4. Divide both sides by 3, and you end up with x equals 4/3 for one of your answers. Sorry, this is getting a little bit messy. Over here we can subtract 1. You get 2x equals negative 1. Divide both sides by 2, and you end up with x equals negative 1/2. Those are your two answers to example T. And that's all I have for solving equations. Hopefully you found this video helpful.